your final example of improper integral. Let's first see why it's improper. I need to figure out when that denominator would be 0. So x squared plus 2x minus 2, that's x minus 3, sorry. That's x minus 3, x minus 1, and one of them needs to be positive, that one needs to be positive, so my denominator will be 0 if x equals minus 3 and x equals 1. Alright, so this function will have two different vertical asymptotes. One I don't care about. Minus 3 is not in my interval. I only care about this function from 0 to 2. So this is the only one that we are worried about. Alright, so I'm going to have an improper integral because at x equals 1 my function is not continuous. And so I'm going to need to split it. Now, this is not the easiest integral. The denominator factors, so this is going to be a partial fraction. So let me solve it without bounds first. Then I'll look at 1/2, and then we'll look at the other half if we have to. All right, so without bounds. So I just told you it was partial fractions. I already have the factors. It's x plus 3, x minus 1. So if I multiply by the denominator, I get 1. I'm going to plug in 1 to make this 0. I'm going to get 4b. So b is 1/4. And then I'm going to plug in minus 3 to get the value of a. I get minus 4a. So a is minus 1/4. So I get minus 1/4 x plus 3 plus 1/4 x minus 1 dx. I get minus 1/4 log of x plus 3 plus 1/4 log of x minus 1 plus c. We have our formula for the integral without bounds. Now let's look at the ones with bounds. So I wanted the integral from 0 to 2. Because the problem point is straight in the middle at 1, or anywhere in the middle really, I'm going to have to split it into 2. I'm going to have to look from 0 to 1. And I'm going to have to look from 1 to 2. As soon as one of these gives me plus infinity, minus infinity, or d and e, the whole integral will diverge. If they both give me a finite number, then the answer will be the sum. Alright, so let's look at the first one. It doesn't matter which one you start with. My issue is at 1, and so I'm going to replace 1 by t. And I'm going to have a limit as t goes to 1. And because 1's the top bound, I should use 1 minus. And then I already have my formula, I already have my antiderivative. So minus a fourth ln of x plus 3 plus a fourth ln of x minus 1 from 0 to t. I'm going to plug in t first. I'm going to get this whole thing. And then when I plug in 0, let me write it here, I'll get minus 1/4 of log of 3 plus 1/4 ln of minus 1, but with absolute value, so this is fine. It's going to end up being log of 1, which is 0. Alright, so now I need to send t to 1. I'm going to get, let me put cheating brackets, minus a fourth log of 4, that's fine. I'll get plus a fourth log of 0, and it's, well, 0 minus, but with absolute value, that's going to be 0 plus. And then I have plus 1/4 log of 3, and when we close the cheating brackets, log of 1 is 0, so that part disappeared, but log of 0 minus absolute value, so that's 0 plus. This is log of x. This is log of x, so 0, I'm approaching this way, I'm going to be going to minus infinity. So this is minus infinity. In some sense, we're lucky. If the first half you look at already diverges, you don't have to compute the second half. I can stop here. This one diverges, and so does the whole thing. All right, so let me look at the graph. I have the graph here. Let's just start at 0. I have my asymptote at 1. The graph looks like this. What we found this integral here gives us minus infinity, so that means this area, well, the net area would be minus infinity, so the actual area net area, and the integral is minus infinity.